Okay, class, picking up where we left off. We added 25 over 40 plus 28 over 40, which gave us 53 over 40. Now we must add 86 plus 49. So this gives us 135. Okay, now we need to take 40 into 53 because this is an improper fraction. We can go off to the side, and for some reason the 35 disappeared. Okay, so we could take 40 into 53. 40 goes into 53 once, and we have a remainder of 13. So we would take this 1 and add it to the 135, which would give us 136. Our denominator will remain 40, and our new numerator will be 13. And that is our final answer. Oh, and by the way, we have to remember, we add this negative and minus. So remember, our final answer has to be negative. So it's a negative 136 and 13 over 40. Now we come to problem number 5. We still line this up. We have 8 and 1/6 minus 3 and 3/4. Now we need to find a common denominator of 6 and 4, which we could scroll up a little bit here. And we could take the prime factorization of 6, which is 2 and 3, and the prime factorization of 4, which is 2 and 2. Now with our LCD, again, these two 2's match up. You count it once. You have 1 2 left over, and you have a 3 left over. 2 times 2 is 4, times 3 is 12. So now our common denominator is 12. So now we will have 8. We bring over our 8 and our minus 3. And our common denominator here will be 12. 12 divided by 4 is 3. So we multiply numerator and denominator by 3. And 12 divided by 6 is 2. Multiply numerator and denominator by 2. 3 times 3 is 9. And 1 times 2 is 2. Now we know we cannot subtract 9 from 2 here. So now we have to go into what is called borrowing. Now this is how borrowing works. First of all, you keep this bottom mixed number the same. So we could carry that over. That'll be a minus 3 and 9/12. Okay, now to borrow, you take 1 from the whole number. So this 8 will become a 7. So we bring that 7 over, and your denominator still will remain 12. Now this is the tricky part. Okay, now we have to get a new numerator. Remember, we borrowed 1 whole from this 8 that gave us 7. Now the whole that we borrowed, we have to write that as a fraction. Now that fraction, we look at this denominator. That fraction that we borrowed would be 12 over 12. Whatever that denominator is, the one that we borrowed will become that denominator over itself. So now we add this 12/12 to 2/12, which will give us 14/12. Now let's go back over that again. You borrow 1 from the whole number, which we borrow here, which will give us 7. The one that we borrow, we look at the denominator and we write that as a form of 1. So the denominator is 12. This would be 12 over 12. If the denominator was 10, it would be 10 over 10. So this 12 over 12 will add to this 2 over 12, which will give us 14 over 12. Now we subtract. 14 minus 9 is 5. Bring down our denominator. And 7 minus 3 is 4. Now that is our final answer. Now there is a simpler way of doing this, but I had to show you all the mathematical process. But the simpler way of doing this is after you borrow your 1, which you know made this 7, you could take your denominator and add it to your numerator. 12 plus 2 is 14, like we have here. So that's an easier way of doing it. Now let's look at problem number 6. Now we had negative 72 and 2/9 plus 27 over 27 and 2/3. Now we know that this number is further away from 0, so we know our final answer is going to be negative. So we could rewrite this as a traditional subtraction problem. So we have 72 and 2/9 minus 27 and 2/3. Now, this is what we would do. We need to find a common denominator of 9 and 3. So we'll put 9 and 3. 9 breaks down to 3 and 3, and 3 we already know is prime. Now, one set of 3's we have in common. We'll write that once, and we'll bring down the other 3. So our LCD is 9. So now we'll bring over our 72, our minus 27, and our common denominator is 9. Now 9 divided by 3 is 3, so we multiply our numerator and denominator by 3. 9 divided by 9 is 1, multiply our numerator and denominator by 1. 3 times 3 is 9, 2 times 3 is 6, 9 times 1 is 9, and 2 times 1 is 2. Now we have the same situation we had from problem number 5. We have to borrow. So remember I told you before, you always bring over that bottom mixed number, minus 27 and 6/9. We borrow 1 from this 72, it becomes 71. And then now we could try that easier way I told you before. We know that the denominator would stay 9. So we could just say 9 plus 2 is 11, and that is your numerator. Now 11/9 minus 6/9 is 5/9. 71 minus 27 is 44. So it's 44 and 5/9. And we must also remember when we started this problem off, the highest number, well, the furthest number from 0 was negative, so our final answer must be negative. So it's a negative 44 and 5/9. Now we come to section C, the application problems. Melissa is making costumes for the school play. Each costume would take 1/3 yarn of brown fabric and 3/8 yarn of red fabric. There are 12 students in the play who will need these costumes. How much fabric of each color should Melissa buy? So what we need to do first here, we need to take is 12 students, and we're going to multiply it by the 3/8 plus 1/3. Or you could have wrote the 1/3 first, that's fine. Okay, so now we know that both of these are yards, so we can include that a little later. So we need to do what's in parentheses first. We need to find a common denominator of 8 and 3. So we could go up here. 8 breaks down to 2 and 4, and then 2 and 2. So 8 breaks down to 3 2's. Now 3 is already prime. They have nothing in common. So your LCD will be all of these numbers. So that will give you 24. So our common denominator here would be 24. Bring down my 12. Now we know 24 divided by 8 is 3. So we know we'll multiply this by 3 over 3. 8 times 3 is 3. 3 times 3 is 9. 24 divided by 3 is 8. So we'll multiply the numerator and denominator by 8. 1 times 8 is 8, and 3 times 8 is 24. So this will give us 12 times 9 plus 8 is 17 over 24. Now, we need to multiply this. Remember, this is assumed to be 12 over 1. So we will have, and we'll write this in prime factorization. The prime factorization of 12 is 2 2's and a 3, and 17 is already prime. The prime factorization of 24 is 3 2's and a 3. Now we simplify out the 2 sets of 2's and 1 set of 3's. So this will give us 17 halves. Now, since we have been working with mixed numbers, let's go ahead and make this into a mixed number. So we'll take 2 into 17. 2 goes into 17 8 times. And we have a remainder of 1. So our final answer would be 8, and it'll be 1/2 yards. That's the total amount of fabric that that she would need. Now, actually, I guess I kind of read this problem a little wrong. This would be the total amount of fabric she needs, but it says how much fabric of each color should Melissa buy. So I need to redo this problem. Actually, class, it turns out that I don't need to redo this problem. what ended up happening is I actually did B. So this portion here is actually what you would do for B. So what I'm going to do for B here, I'm going to do A. So now we're going to do the directions for A now. It says how much fabric of each color should Melissa buy? So we would take 12 times the 1/3, and then we will also take 12 times the 3/8. Now remember, the color of the fabric, as stated here, was you have 1/3 yard of brown and 3/8 yard of red. So now we would take this. We would take 12 times 1/3. So we'll put 12 over 1. And we'll take the prime factorization. 12 is 2 times 2 times 3. And 3 is already prime. These 3's will simplify out. And that will give you 4 over 1, which will give you 4 yards. So that is of the brown. Now we will go here, and now we would do the red. So we could write 4 yards brown. Now we would do the red. So we'll make this 12 over 1 and do the prime factorization of 12, which is 2 2's and a 3. And this 3 is already prime. And our denominator prime factorization of 8 is 3 2's. These 2's will simplify out, and you will have 9 over 2. And then we could take 2 and a 9, which goes 4 times. And we have a remainder of 1. So our final answer is 4 1/2 yards red, since we know we're dealing with fabric. So it's 4 yards brown, 4 1/2 yards red. Now this is A, and remember what I did up here was actually what was for B. So now we scroll down here to number 2. It says a stretch of highway that is 45.5 miles long is being resurfaced. The company doing the work estimates that it can resurface 1 1/4 miles in a day. How long will it take the work to be completed? This is a division problem. So we'll take 45 1/2 divided by 1 1/4, because we want to know how long will it take the work to be completed. So we would take the improper fraction. We'll make this 45.5 into an improper fraction, which will give us 91 over 2, divided by 1 1/4 will give us 5 over 4. So we add 91 over 2 times 4 over 5. Now we would take the prime factorization of these values here. Now 91 breaks down to 7 times 13, and 4 breaks down to 2 times 2. In our denominator, we had 2 and 5, which is already prime. These 2's will simplify out. In our numerator, we have 182. In our denominator, we will have 5. So now we would take 5 into 182. 5 goes into 18 3 times. And 5 goes into 32 6 times. And we'll have a remainder of 2. So our final answer would be 36 2/5 days. Now we have number 3. Ben's backyard is 32 1/3 yards long and 18 3/4 yards wide. How much fencing would be required to fence in the entire backyard? Now, you know, fencing is the outside of the backyard, so we will use perimeter. And most people's backyard is in the shape of a rectangle. So we will use the perimeter of a rectangle, which is 2 times the length plus 2 times the width. So we have perimeter is equal to 2 times the length is 32 1/3, and the width is 18 3/4. Now we know that this is in yards, and we can write the yards later. So we have to change these mixed numbers to improper fractions. So this will be 97 over 3 plus 2 times 18 times 4 is 72, so it'd be